Everyone okay so far? Question? Yes, exactly. Yeah, so I saw that I had a t in both already, but I don't have the square root of 1 plus t in the other one, right? So I'm trying to get them to match up. Yes, good. Simplifying upstairs, I get minus 25t over that same denominator. Yes, it's a pain to keep writing this, but tough. Get over it. And then my t's cancel. And I'm finally to a place where I can plug in t is 0 and not get 0 over 0. So I'm ready for my limit. Once I plug in, I no longer use my limit symbol. Yeah, you're not copying me. You're not copying me, right? You're not copying me. You're doing the work, right? It's no sense. You don't need to copy me. Do algebra, right? Once I plug in to t is 0, I'm just doing arithmetic now. You don't need to copy my arithmetic. Right? I mean, not much calculus here. Not much calculus here. This is really something that's trying to but, a number 4 on what? Oh, yeah, yeah. So on 3, on line 4 in black, what I had once I got my LCD. Okay? And then I'm seeing that I have a conjugate. I have a radical. Right? I got 5 minus 5 square root of. And so that's where I'm using my conjugate. Again? Yeah, so I might need a conjugate in the numerator. I might need one in the denominator. This one I have one in the numerator. Right? I have a number plus a radical. Right? Or something plus a radical, or minus a radical. And so I take the conjugate and over itself. So I can only multiply by 1. Is there a radical in the denominator? Yes. Does it have a conjugate? Yes. Will it help me? No. This is t squared root of 1 plus t plus or minus 0. That conjugate isn't that useful. It's not going to drop out middle terms. I think that's what you're getting at, right? Good. How we doing? Anyone get there? Anyone get there? No one got there? Thank you. You got there? Question? No, got it. Good. Yeah? Get it? Okay, no, so right here on line 3, notice I'm only working on that second fraction. Once I get line 3 done, I have in black on line 4, I have the LCD, but upstairs is a 5 minus 5 square meters.
You see it? Yes. All right, you got to get to work because you didn't try this problem yet. I don't know why, right? And now we're doing it. We're having trouble with it, right? So get to work. Get some work done this weekend, okay? All right, let's do our new stuff. Are we ready? And when I'm asking you, when I'm doing a problem, I don't want you just copying me. It's not the same as doing it yourself, right? You have to think about what steps you're going to do and then just do them. You can't just look at a problem that's finished and say, "Oh, I get it." You have to start from the beginning and write it on your own. That's what you have to be able to do. And I guess we've already done 100 problems together, so you should be able to do them all. Right? Wednesday, at the beginning of class, I'll answer questions. Wednesday afternoon, we have a quiz. Right? Probably around 12 o'clock. 10 minutes a problem. Jack, you okay now? You got it? Yes, me too. Yep, nice. And make sure you're practicing checking things on Desmos, right? Because you'll be able to do that on the quiz. Yeah, question? Ipsa? Yeah, always at the end of class so that if you know how to do them, you get out early. Yeah, Nathaniel. Algebraic limits only. So either factoring, LCDs, conjugates, or a combination of them. If I'm looking at the old quizzes, and you can mark this down right now as I go through them, which ones do I like? The first page. Second page, there's a conjugate, right? Third page, there's factoring. We did that one Wednesday. Not the fourth page, that's continuity. Not the fifth page. No, that's it. So just those first three. Oh, there's one. Quiz 2.3, that's a good one. That's a LCD and a conjugate. I forget what page I'm on now. Oh, page 8. So 1, 2, 3, and 8 so far. Yeah? Ah, look at that one. Look at that one. Recognize it? We just did it, right? With a T and instead of a 1 upstairs, a 5. So I like that one. Page 9, 1, 2, 3, 8, and 9 so far. Yeah? Yeah, I like this one. Page 10. Yep, like this one. Page 11. Not 12. Not 13. That's enough, anyway. So it was page 1, 2, 3, page 8, 9, 10, right? Nice. You can send me work over the weekend, right? You could schedule time with Dr. Early over the weekend. Right? office hours, a half hour before class and a half hour after. Okay? Not today, I can't do a half hour after today, but next week I can. And then I can also do office hours at every other times. You're going to send me an email and say, Robert, I need some help on some problems. Can you meet? Yada, yada, yada. I'm free this time, this time, this time, this time, and I'll pick one that works for me. Question, Elizabeth? Say again? I always give at least 2 questions, which is 2 quizzes. So 10 points per quiz. They're not what? No, I don't like makeup tests or makeup quizzes. It's probably because the eyeshadow is very hard to put on. I don't like any makeup tests. No makeup test. So if you miss a quiz, you get a 0. If you miss a test, you get a 0. So don't do that. Now, I do drop quizzes at the end of the semester. I usually drop 5. So sometimes there's a day when you can't be here. You can miss a quiz on that day and forget it. Right? Try not to get more than 2 quizzes during the class. Which is fine, even if I give only 2 quizzes every class, 2 questions every class. You'll have some like 25 quizzes at the end. But don't miss them now, they're too easy right now. Right? So I like a quiz on this material Wednesday, on Friday this material, and today's material for Friday. For Wednesday's quiz, I like algebraic limit, factoring, LCDs, conjugates. For Friday's quiz, I'll put in another one of those, right? And this new material I'm teaching today. Question? Yeah, it'll always be 2 quizzes. It will never be less than 2 quizzes. It'll always be 2 problems or more. Okay? So, but for now we're starting just with 2 problems. So, I mean, just do all the problems we've done. You'll be ready, right? Yeah, question? 2 questions. So first question might be with a conjugate. Second question might be just with factoring. Right? Does that make sense? 2.1. 2.1. So we're ready to go. Let's go. So we're saying, we're talking about the secant tangent problem here. Secant tangent problem. Looks like I'm having a little bit of a hard time writing. Secant tangent problem. Man. There it is, tangent problem. I just can't get the pen to work right today, sorry. Secant tangent problem. So, we've done secant problems before in pre-cal, right? We have an x sub 1 and x sub 2 on our axis. And then, of course, we have a x sub 1, f of x sub 1, right? X sub 2, f of x sub 2. And we're drawing the line between those 2 points to get what's called a secant line. If you remember in high school geometry, you had secant lines of a circle. The secant lines of a circle, secant of a circle, is a line that hits 2 points on the circle, and a tangent that hits 1, right? So this is my secant line. And of course, we're interested in finding the slope, which is easy, right? So the slope of the secant we call it m, right? Is what? F of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1, right? And you remember doing these in pre-cal with an initial of dq. You remember that? What was that in pre-calculus?
and here's the D, and here's the Q. Remember doing those in pre-calculus? Just say yes. Good. Difference quotient. Remember difference quotients in pre-cal? Difference quotients in pre-cal, yes or no? Lying, I think, but that's okay. I like rather you lie to me than just be quiet. So what we're going to do is we'd like to find the slope at one point. Oops, nice line there, Robert. I'm really interested in the slope at one single point. Oh boy, having trouble today. And I'd like to think of myself there on that hill skiing, right? So I'm skiing on this hill, got my headphones on. Okay, I'm skiing on that hill. Everybody understand the concept of skiing on a snowy mountain and you've got slippery pieces of wood on your feet? Yes? So I'm interested in the slope of my feet at that one point. Right? Imagine I had a time machine, I could just stop time. So there I'm swoosh down the hill and stop. And right at that point my skis are at this angle. Yes? I want to figure out that slope. But the problem is I need 2 points to figure out a slope. Right? So when I'm on that one point, there I am on that one point, I want to be able to guess the slope of the tangent by thinking about the sequence, right? So I really want to think about that secant, and then the green one, and then the gray one, and what's happening to the slopes of those secants, right? Red, green, gray, it will help you predict the purple slope. And what's happening to x sub 2? It's becoming x sub 1. Right? But when x sub 2 becomes x sub 1, I'm going to have a 0 over 0. What did we do when we had a 0 over 0? Found a replacement function. Right? So I'm going to redraw this picture, and I'm going to use different notation. There's 3 bits of notation I'm going to use. What we used to use in algebra was this x, right? x1, y1, x2, y2 thing. But I'm going to change it to x and x sub x plus h. And so I have now the 2 points are f of x, x comma f of x, and x plus h comma f of x plus h. And what's this distance right here? So look what happens to my slope of my secant. It is f of x plus h minus f of x. There's my difference. There's my quotient, x plus h minus x. And what does that simplify to there on the bottom? Just h, yeah. So this is now the slope of the secant line with an x value known and an h value known. When will I get my slope of my tangent line? When do I get the slope of my tangent line? How do I get the slope of my tangent line? Yeah, take the limit. And let what go to what? H goes to. I'm going to take my limit of the secant slope as h goes to 0. As this point moves to that point, right?
then I'm going to get I'll be able to predict my tangent slope. So meaning the limit as h goes to 0 of the secant slope of this difference quotient is going to become the tangent slope. I'm going to get a function out of this, and I'm going to call it f prime of x, which is also called the derivative. And that derivative gives me the slope of the tangent at any point. Okay, everybody on Desmos, please. How are we doing here? We okay? So I want to start with a nice simple function. Let's just use f of x equals x squared. What's nice about this is, well, if you're logged into that, you say you get it, and then if you want to use as concept again, you can just change the function. Right? Backspace on the x squared and make it the next function. I want to put two arbitrary points up there. I can't use x because Desmos understands that as a variable. So I can use any other letter I want. Well, not e, not pi kind of thing, right? But I'm going to use a. So a comma f of a. With a slider a, I click on that to make it a slider. And now I can either move the point myself with a mouse, or I can move the slider to move that point on my curve. Right? You with me? That working for everybody? Yell for me if you need help. You can see that point moving on there, right? I want to put the second point up there. What point am I going to use? Not a comma f of a, but very good, class. A plus h, comma, f of a plus h. And I add slider h. Everybody okay? Play around with it. Change h. Make h go to 0, right? Change h is not 0, change a. Right? You'll see h kind of goes along with it, right? You see what I'm saying? So if I move h to be 0.3, but then move a, look at those two, they stay 0.3 apart. You see what I mean? Yeah? Is that working for everybody? So now if I connect these two, I have what? A secant line, right? What do I need for a secant line? What do I need for a line? I need a slope and a point, right? Yes? Is everybody okay? Everybody have this sketch? Anybody need help? Here, Jack, what's up?
Oh, we need to call that. Should be on the slide. Okay. Okay, you got this slide. This slide. Okay, there it is. Good. H is just too big. It's too big. It's too big. And remember, H is the distance between the 2 points in the horizontal direction, right? All right, I need a couple of things for a secant line, for any line, yes? And remember, you have a formula sheet, right? So this line is going to go on there. We need our equation of a line. And we're going to use the point slope formula. So I have y minus y1 equals m times x minus x1, right? You remember seeing this before? Just say yes. This is the college equation of a line. The y equals mx plus b is the middle school equation of a line. So you're going to get used to using this one, right? You don't need the tattoo because you got your formula sheet, right? Good. What was my x1, y1 in my problem? In that last problem I just did, what was my x1, y1? A, f of a, right? Yes, you agree? What was my slope? F of a plus h minus f of a all over h. I like to get that one in my Desmos right away. So I'm actually going to do this calculation in Desmos. So I'm going to write it again in Desmos right here, right? I want to know the calculation of the slope of my secant. I'm going to just call it m, and that is f of a plus h minus f of a, highlight it all, divided by h. And there I've got a calculation of my secant slope. You with me? There's Dr. Early. Hello. Dr. Early is here. Dr. Early, let me just finish one little piece here, and then we'll give you the floor, okay?
I like the rest of it.
Yeah, that's fine. So everyone okay here with my secant slope? Okay, now the equation of the line, what is it? Y minus what? What was my y1 value? F of what? F of a equals m times quantity what? X minus what? Don't we have it on our paper? X minus x sub 1. What was x sub 1? A. Whoops. And there's my secant line. Let me know if you don't have it. You have the slope calculated and you have the secant line showing up to your 2 points. What's that? Everyone's okay? So, if I change my h value, right? If I let that h go really small, and it's a nice way to change h is just to say something like between -1 and 1 by a step of 0.01. So I can get h really close to 0 right? 0.6, 0.5, 0.3, 0.1. Yes? You see what I mean? And I'm getting closer to my tangent line. It almost looks like a tangent line, doesn't it? Almost looks like a tangent line right there. But there's still 2 points. I don't know if you can see them, purple and blue. Right? So I can make a pretty close prediction for my tangent line. Right? Maybe 0.6, I think, maybe. Right? So, but the idea is, if I have a fixed A, like for example 0, and then I move my H closer to 0, what kind of line am I going to have when I get right to H is 0? What kind of line is it? See it? Can you see me standing at the bottom of the valley with my skis and my music on, right? And what's the slope? What am I standing on? What slope on the ground? When I get here. When I get here. 0. So look at my prediction, look at my secant line, right? Let my secant line go down to 0.1, 0.08, right? What's my slope going to? Do you see it? So look, really close, and H is 0.2, 0.01. My slope is 0.01. On the other side, if my H is negative 0.02, the slope is 0.02. So I'm able to predict what's going to be my tangent slope. And it's obviously what? Into the Z. 0. Right? So this secant slope is helping me predict the tangent slope. So what's nice about this is I can always go back and change my function. So if I want the square root function, right, everything jumps to my square root. It's nice to have this saved. So I'm saying to you, eventually create a Desmos login, and when we do sketches on Desmos, save them, right? Name them something appropriate, right? Secant slope, this one, right? Difference quotient, right? Well, Dr. Early, I've just got one problem to do today, but I'd rather you take the floor now before I start it, because it's long.
Okay.
Is that okay?
Yes.
Do you have any comments on this for?
Yes, I first learned the snow ski when that gravel was there, and the A was equal to 0. They called that the bunny slope.
Yes, the bunny slope.
And I just love the bunny slope. Here you guys go snow skiing. When you first go, you want to go on a bunny slope, where the slope is almost 0.
Almost 0, so you're just like kind of like you're moving it like this fast.
And you can tell everybody on Monday, I went skiing. Because you didn't have to worry about falling.
Yeah.
Because gravity is equal on both sides. So class, I think some of you read the email I sent you this morning. I am your academic coach for the whole semester. College has assigned me to be your coach. If you get stuck on a problem or homework, the professor says you can come in before class during office hours and he can help. If you have other questions, your professor says you can stay after class. Well, what are you guys going to do on the weekend? Well, I'm available on the weekends through Zoom if you get stuck. We don't want you to have to wait until next week. So, if you're working homework and you miss the concept and you don't know the next step, just go to the link I sent you in the email, schedule a session, and we can get through that hump really quickly. Even in the evenings during the week. So my schedule is in the link I sent you. The college started this program 6 years ago. The college made a promise to the community that any student who wanted to succeed, really wanted to succeed, college would expend extra resources to help you succeed. So they install academic coaches in several classes, in some English classes, in biological science classes, in physics, in mathematics, in computer science. We want more students to be successful. As Professor Kuhar has told you, it takes a lot of work to learn geography. And you're going to have to do a lot of work. And normally that means there are a lot of hills that you may get stuck on. So don't be shy. Please see your professor or see me so that you don't fall behind. If you fall behind, you can schedule several sessions with me to catch up. So never give up.
And those are Zoom, correct?
Those are Zoom. When the program first started, there was no Zoom. So we had study groups, and we would ask the class, the academic coach would ask the class, what's a good time that you guys want to meet once a week? And most of the time we would meet right after class in a classroom close by. So we can still do a study group. Those who want to do a study group, email says, please let me know what's a good day and time if you want to do a face-to-face study group. In the meanwhile, you can do Zoom. Pandemic showed us that we can reach more students using Zoom. So, Zoom or face-to-face, whatever you're stuck, please let me know.
Do we have study groups in here yet? Anybody study group? Nice. Look at that. Isn't that awesome?
Yeah, that's fun to work in a study group. Because students think alike.
Yeah.
And then they learn together. And they complement each other.
Yeah.
Professor Kuhar and I both did study groups when we were
So it saved me. It did.
And then he knows everything back and forth. So you can do like that too. So I want to thank you, Professor Kuhar.
Yeah, Dr. Early, I would also invite you to pick Dr. Early's brain about his career and where he went to school, undergrad at Howard.
Undergrad at Howard.
Electrical engineering.
Yeah.
So took all the math that you're going to take. Then
And I went to graduate school in California at Caltech,
Caltech,
Pasadena.
Pasadena. Very, very tough school.
Yeah.
Very challenging.
And then I went to industry for several decades working in satellite defense industry. So it was very exciting and enjoyable. And now I'm giving back to the community. And my favorite subject is mathematics.
Yep. So Dr. Early, you were department chair at Howard.
Oh yeah, I came back to my alma mater, department chair.
Electrical engineering. So, any kind of engineering question you would entertain?
Yeah.
Like what should I, I want to build this, what kind of engineering, what kind of engineer should I be, or right? I had a couple of, boy, what was our question? General engineering or electrical before you transfer?
Oh, okay.
So that might be something you could have a conversation with Dr. Early about.
About career and educational planning for the career.
Yeah.
And what is it like to be an engineer?
Right.
Should I be a computer science person? Should I major in mathematics or physics?
And the connector with all of our careers that we're thinking about is we're going to have data. Think of the special bio pieces, you're going to have data. Stats, of course, computer science is going to have data, right? We're all going to have things changing. So there's the calculus. And of course, computers, we're going to do everything on the computer, so it's still a nice connection to everything you did, right? Data, mathematics, computer science, all toward this application of electrical engineering, right? We're all going to do the same thing. whether it's bio or computer science or some kind of engineering, right? So pretty exciting. So you got a superstar here. You got Michael Jordan here to help you. You got someone who has done everything he could have done, went to the most challenging schools, right? And now he's saying, hey, I want to help you get a foul shot. Imagine Michael Jordan, you don't even know who Michael Jordan is. LeBron James, how's that? You got LeBron James here. Or who's the Williams sister right now? Who's like Serena. That's, I'm just saying. You got a superstar. So let's take advantage of him, right? And believe me, he wants to be here. I want to help. So you're doing a problem, you're checking it on Desmos or in the back of the book, you get it right, you compliment yourself. You say, hey, I got that one, right? You go do another problem, you get it wrong, right? Whether it's in the book, back of the book, where you use Desmos to check it and it's wrong, what are you going to do? Well, you're going to try it again. Maybe look at your notes, maybe do a Google search. If you're still stuck, what are you going to do? Send it to Robert in an email, and maybe schedule something with Dr. Early. Don't keep working on it. Don't keep torturing yourself. Don't waste time. Don't do 10 problems and not check them and then look at them all and see that they're all wrong and you wasted 2 hours. You got to work smart, right? So it's also good, I think, to let things go. Like when you're at a party with someone and you say, oh, who is that actor? And you could look it up in the magic box, of course, but wake up in the middle of the night and you say Sidney Poitier, right? Or Tom Cruise or whatever. The brain needs that defrag time to kind of put things together, so you can go practice that problem again later, right? Or you could skip to a problem that's different. You're like, oh, I hate the ones with the radicals, so let me just do ones without the radicals, right? So, but you have to think smart and you have to ask for help. Dr. Early and I have had about 6 classes together. All our early college classes, we had about 90 to 95% passing rate. We just had one together in the summer, but no student went to Dr. Early. No student asked me for help. I had 8 students, 2 A's, a B, a C, and the rest F. So there's a 60% passing rate. And we got our embedded coaches in our classes, in the classes with the lowest passing rate. So we can fix that. We want to get you through Cal 1 the first time. Okay? Anything else, Dr. Early? Oh, yeah. Yeah.
Thank you.
Nice. Look at that, Michael Jordan. What's your sport, Dr. Early?
My sport. Well, I was on the rifle team in high school.
Are you serious?
Yeah, I was captain of the rifle team. Only this muscle.
Yeah. That's the only.
Refused to earn a letter. I got
Yeah.
a letter.
Yeah, so you practice with that all the time, right?
Yeah. And I was so excited to get my varsity letter.
The only superstar in rifling I can think of is Annie. Who is that? Oakley? Annie Oakley.
Yes, Andy.
That's the only one I can think of. I don't know many other riflemen. Superstar.
Rifleman.
The rifleman was, but he's a.
Clinton.
Eastwood?
Clint Eastwood was the rifleman.
Oh, that's right. That's
That was
right.
a weekly
Yeah.
TV show.
Yeah.
And we didn't know he was going to be a superstar.
Yeah. Thank you. You got lots of help. The hardest thing is asking for it. I know this personally. I need help in everything. And like when I get overwhelmed with laundry, right? I say to my girlfriend, just hit me in the butt today so I can get the room straightened up, that kind of thing. We just need help. But you gotta ask for it, okay? All right, beautiful. Here comes our problem for 2.1, right? So we're going to take a look at the book here. Uh, 2, 4, 6, 7, 12, 13, 16, 18, 19 students today? What the hell? Chris is not here. Is that correct? Chris is not here. Luis is not here. Angel is not here. Felicia is not here. Brian is not here. And Laura is not here. Okay, nice. Good. WebAssign. Everyone can get in the book so far, all right? Molly, you're the only one that's having trouble. Anybody else not able to get into the book yet? Okay, good. Just want to look at one problem. So I think I assigned number 1 through 9 in this, right? That first page that I told you, 2.1, 1 through 9. Of course, that means 1, 3, 5, 7, 9. Do it informally, okay? So you don't even have to write it down. You could go right to Desmos. You could write it on the bathroom mirror with a you know, what do they call expo markers, or on a window. I used to do that to save paper. You can take paper, okay? You may take paper. I'll do anything I can for you, okay? So I want to just look at one problem here in the book. So once I get the book open on my page, there's a little indices here, kind of a guide to it. So if I want to get the problems in 2.1, I like to go to 2.2 and then back up. So I'll go to 2.2 and then I'll back up to problems 1 through 9. Here we go. So I want to do, so you see it's a bunch of H and H plus 6, this and that, all of that. Let's see, which one do I want to do? Sure, I'll do number 6. So let me take a photo of it real quick. Oh, God, you can't see that either, can you? It doesn't matter. I'm going to write it on the next page, okay? All right, this is all about that secant tangent experience. I want to talk about secant and tangent real quick. Secant is the average velocity. But if I'm talking about velocity, I'm talking about driving to work, right? I live 10 miles away. It takes me an hour to get. So the velocity, average velocity is 10 miles per hour. But at one point, I got a speeding ticket. I saw the light hit twice. At that moment, I was going 50 miles per hour in a 25. I drive fast, I'm sorry. So, average velocity was 10 miles per hour. Instantaneous, that velocity at that very moment, 50 miles per hour. Right? Making sense? So, if you think about that speed camera, if you ever see one go off, it takes 2 photos because it's getting me a delta Y and a delta X. Right? So we're trying to get those 2 points really close to each other to figure out what speed I was going at that time. It's my tangent, the slope of the tangent line. Is that making sense? Okay, so we have a particular problem here. This might help a little bit. If you notice, I have 2 points on the curve y equals. Can you see it at all? Oh my God. I'm sorry. Very blurry, isn't it? Is that any better? Ah! Damn it. There we go. number 6. That any better? Can you see it a little bit? So I have a curve of y equals 1 over 1 minus x. We're going to put that into decimal for sure. And then I have a fixed point, 2 comma negative 1, and an arbitrary point, x comma f of x. So, into Desmos. Yes, you're with me. If you want to save that sketch, you can just open a new window. So I have the function 1 over 1 minus x, correct? Whoops. There it is. And I had a fixed point. Does anybody remember it? Thank you. 2 comma 1, right? Yeah. Oh, 2 comma negative 1, yes. Thank you. And so I could see that point. I want the slope of the tangent there, right? And if you can imagine me skiing on this, what am I probably doing right here? I'm screaming. Right? If you can imagine my slope there, I'm screaming. Oh, it's just because I was stretching it before. I was stretching it. You know, we understand this anymore and this, right? I can make the scale, doesn't matter. But I can go and make the scale inside of that wrench tool. I can make the scale perfect. Or I could open a new window and do square. I want to think about my secant line. So I'm going to add in my other point, right? And I guess I want to use a plus h, but a is fixed for me, isn't it? You agree? A is 2 now, right? I got 1 point fixed. I want I want the tangent line there, right? So I have to pick some point later for the tangent line, right? So I'm going to use 2 plus h, a plus h. Do you get that? Comma, f of 2 plus h. So there's my second point. Yes? You with me? Before, remember we could control both points. We could move a. But I don't want to, in this problem, in the problems in section 2.1, I'm going to have a place where I'm concentrating at, and I'm going to keep it as a fixed number. And the book will tell you what the fixed number is. So I know I want the tangent line at 2. That's what the problem is reading to me. Right? But I want to think about that sequence. Yes? You with me? So, I want my slope again. What is it? It's f of 2 plus h minus f of what? Where's my fixed point? F of 2, right? All divided by h. So take a look at the textbook here for me. I already closed it, I'm sorry. But I'm going to read it to you. It wants me to figure out the slope of the tangent line, right, for certain values of x. So it gives me it gives me 2.1, 2.01, 2.001, but I know that the fixed value is 2, so I'm really looking for h values there, right? I'm looking for h values. So if I say 2.1, h is what? If I say I want the x value at 2.1, I already know x is at 2. I want h to be what? 0.1, right? 0.1, can I get there? Yes. Somehow, there it is. So look at my slope, 0.909090, right? Repeating, yes? Then it gave me 2.01, so I want h to be 0.01. I got to change my scale to get that. So I'll say h is between -1 and 1, and I can go by a step of 0.01. Whoops. So now I can get my h value down to 0.01, and now look what I have, 0.99, right? 990990099. So I'm going to be able to predict this, right? Okay, but better than that, I want to look at the slope of my secant line and see if I can figure out the slope of my tangent line by taking a limit. So here we go. So this is 2.1, number 6, right? I have this curve, right? And this is 2, -1, and this is some arbitrary point. I think it'll be easier to do it like this: x over f of x, x comma f of x. Let's get my secant slope here, right? Now notice if I use it like this, I only need an x value. So when the book gives me direct x values, I can use the direct x value. So what's my secant slope here? y2 minus y1 over x2 minus x1. Can I plug in 2 here? No. I get 0, right? 0 over 0. So I want to simplify this. What am I going to use? What am I going to do here? Do I have fractions within fractions? What's my only denominator, interior? 1 minus x, right? So I'm going to multiply this by 1 by the LCD of the interior denominators. This is going to get multiplied to the numerators, right? So I get 1 minus x over 1 minus x. Don't let me go too fast here. And then I get x minus 2 times a 1 minus x. Can I plug in x is 2 here? No. But I can simplify. So upstairs, what do I get? 2 minus x? So far, this is the secant slope. This is the secant slope for any x except for 2, right? So I put in a 2.1, a 2.01, a 2.001, right? Can I simplify anything else? Yeah, take out a negative upstairs, and then I get a factor of x minus 2 in the numerator and the denominator that cancel. So I get my replacement function of 1 over 1 minus x. And of course, I can make that even prettier by saying, put that negative into the denominator. This is the slope of the secant function when x is not 2. It's the slope of the tangent function when x is 2. So the book wants you to do a bunch of secant slopes and try and predict the tangent slope, right? Everybody with me? All right, I want to plug this secant slope into my calculator, right? So I've got a new function here. Let's call it g of x, or m of x. Doesn't matter. And I got 1 over 1 plus x, x minus 1, right? 1 over x minus 1, is that right? I don't need to look at the graph, really, but I do want the values, and I can do this right on, I don't have to do it by hand. You can do it by hand, but I wouldn't. I want to do a table for that, for the x values that they're prompting me for. And they prompted me for 2.1, 2.01. Uh-oh, what's going on? Oh, sorry. I'll use g of x here. So this is the slope of my secant line at 2.1, at 2.01, at 2.001. What are you guessing? 1, right? Yes, you with me? I'll do a crazy one just to see. 0.0000001. 0.9 repeating, so we know that's 1. But because I've got this thing simplified to be a tangent slope, I can just plug in 2. So by doing that algebraic replacement function, I can plug in values of x for a secant slope, and I can plug in the value of interest for tangent. Kind of confusing, I know, but take a stab at it. We'll talk about it Wednesday. Wednesday we have a quiz, 2 questions. I'll give it to you at 12 o'clock, just 10 minutes each for each question. And you'll be answering algebraic limits. Okay? On Friday, you have a quiz. I'll give you another algebraic limit, and I'll give you some problem where you have to look at the secant slope and a tangent. All right, have a great weekend. See you Wednesday, right? No class on Friday, right? No class on Monday, sorry.